Today we'll explore Thales' theorem, one of the most fundamental theorems in geometry. The theorem states that if we have a circle with a diameter AC and any point beyond the circle, then the angle ABC will always be 90 degrees. Let's start by drawing our circle. We'll draw a diameter AC and mark the center point O. Now, let's choose any point B on the circle. To prove this theorem, let's draw some additional lines that will help us. First, let's draw the radii from the center O to each of our points A, B, and C. Since these are all radii of the same circle, they're all equal in length. Now, let's look at the triangles we've formed. Triangle OAB is isosceles because OA equals OB. Similarly, triangle OBC is isosceles because OB equals OC. In isosceles triangles, the angles opposite to equal sides are equal. Here's the key insight. Since AC is a diameter, points A, O, and C form a straight line. This means that the angle AOC is 180 degrees. Therefore, angle AOB plus angle BOC must equal 180 degrees. Now, let's put it all together. In triangle OAB, the base angles are equal, so each is alpha degrees. In triangle OBC, the base angles are equal, so each is beta degrees. Since angle ABC is the sum of these two base angles, and we know their sum must be 90 degrees, we can conclude that angle ABC is 90 degrees. And thus we have proved Thales' theorem. If a triangle is inscribed in a semicircle, the angle inscribed at the point on the circle will always be 90 degrees. This is one of the most elegant and useful theorems in geometry.